cardiovascular system is getting affected, endocrine system, respiratory system, immune system, inaugmentary systems. Likewise, entire system is getting affected. So just even one system fails, then it's going to be a very serious impact for us. But this air has an impact. That is, our indoor air quality has an impact to affect our 5 systems. Okay, just come to next slide, Vishnu. Okay, done. So here, if we see all dust particles, it is not only dust. Yeah, please understand. It's not only a dust. Even a dog, you will have a pet, right? Pet will have some pet airs, and it is going to generate. And painting, right? Paint, whenever we paint, they'll say, even in Shah Rukh Khan also will say low VOC paint. It's a very low VOC. Low VOC is nothing but volatile organic compound. Everybody knows paint will emit, definitely there will be an emission. But in today's market, people are saying that it's a low VOC. Low VOC in the sense it is going to emit very lesser volatile organic compound. So that is where we used to call low VOC. But we have to be selected in such a way we cannot avoid. See, for example, if you are going to paint an MS support or a steel kind of thing, if you're going to paint, we need a kind of an oil paint. So the oil paint, definitely it's going to emit the VOC content. So that's where building before, if you are after construction painting work is done, people, they'll open the window for maybe a 3-4 days, because the complete thing has to move. Even if you see in a LEED, that is where LEED rating system we are saying, right? Green building system. They are giving certain credits. What they are saying is, our building has to be run. That is whatever the space, they should have one small exhaust fan. It has to run for 3-4 days continuously, so that the entire VOC content from the space, it is going to be exhausted. If you are doing that exercise, we are going to add one credit. That was the point given by the LEED. It's a good right. See, any building, if you're not putting any fresh air, or if you're even, I'm painting it, I'm going to close and I'm going to switch on the air conditioning. Yes, it is going to be recycled within the R spaces. Okay, so ducting, everything is going to settle in the duct again and again. It is continuously, it's going to recirculate. Okay, so we have various components. Various components are there. Various chemical terminologies are there. It is there available in the air. So that has to be removed. That can be removed by either different technologies. If, for example, by adding a filter, we can remove it, or we are adding some chemical reaction, or it has to react with some other component, so that is going to be removed. I still remember in my career in 2011, I was attending in a presentation. They used to call as an ionizer. Ionizer is nothing but which is going to react with the smoke, and that is going to decompose the smoke into a dust particles. Okay, so because if the smoke is there in the active, it is going to be harmful for us. Okay, this ionizer, what it is doing, it is going to react with the smoke, and it is going to be converted as a dust, and it is going to be settled in the floor. That it is not, it is that dust doesn't, it's going to have a very serious effect. So since it's a dust, we can you can wipe it. Okay, the guy who took these cigarettes, and he just blow into a small box where the ionizer has been placed. Within a fraction of a second, the complete smoke has been gone. You cannot see the smoke. Even I couldn't see the dust also. So that's where the ionizer, the technology is getting improved. But unfortunately, this ionizer is not a proven technology, because any natural thing, it's going to be natural, right? So any fresh air generated by trees is different from the fresh air generated by ourselves, right? So that has a various different impact. So I'm going to share some strategy. What are the different how fresh air can be improved within our space? Okay, move to next slide, Vishnu. Okay, so if you see here the investment cost, okay, almost 40 square feet per 40 rupees per square feet. That is the cost we are investing in the HUs. But whereas we are spending 180 rupees in the carpet, 300 rupees in the construction, partition 300 rupees, all we are spending highly we are spending on the other part. But whereas we are spending only 40 rupees, it's hardly not even 30% or 20% cost that we are considering in our investing. But unfortunately, this is going to be helpful for us. The carpet is going to emit the dust, or it is going to emit this VOC content, but HU, which is going to remove. But we are investing very less amount in the HU, but we are investing the high thing. And I would like to know, see, if you take a person, there will be expenses done by the company, right? Some company will have some expenses, right? Can you say in which they are spending more? Assume there is a company on how a person, how much percentage of cost is being spending on the person. See, for example, the cost for the person is spending around for food they are spending 20%, for expenses they are taking 30%, and for salary they are taking something 20% or something like that. Can you specify the percentage if anybody knows? I've already given the answer, but that's not a right figure. I've just given it. I want the figure, or else I will put in this way: expenses towards is productivity, expenses on the infrastructures. Can somebody say what is the percentage? I'm a company. Assume I'm a company. I'm giving so and so percentage for Vishnu. This is going to be your salary, because your productivity, based on your productivity, I'm going to pay so and so percentage. Balance percentage, I'm going to put it in your infrastructure. That is office infrastructure. Can I have your answers from your side? 20 to 80. If you can specify what is 20, what is 80, or 20 to 30, or 20 to 80, if you can. Productivity 30%. I would say salary you are paying 30%. Am I right, Kana? Okay, so you're saying that 30% you're paying 80% infrastructure. Okay, 30% for productivity. That is, I'm taking two factors. One is productivity, one is salary, and another one is infrastructure. So Dilip Babu says that 80% on the infrastructures. Okay, 20% for salary. Any other answer? 40% salary, 60% infrastructures. Great. Next. I'm expecting two more answers. With this we can close. I'm going to answer for this. Okay, fine. I'll tell you. We are spending 80% of investment on the employee salary. Okay, 20% on the infrastructure. Please understand, infrastructure is being designed only for a year, or it is going to be spent. The cost is being spent for a year. With that infrastructure, we are going to live more than 30 years, or 20 years, or 25 years, something. But we are spending only small amount of cost in the infrastructure. 80% of the cost is for employee cost. Okay, because employee salary is getting increased by year. Their salary, they have to pay higher amount to the employees. So any company, if you see 80% of their costs on their infrastructure, and 20% on 80% on their salary, and 20% on this infrastructure. Just imagine if the guy is taking a leave because of this health issue, his productivity is getting closed. Okay, the moment the productivity is getting closed, just imagine company is taking you. Okay, company is going to take you, say for 100 rupees. Assume 100 rupees. Okay, they are going to pay only 50 rupees for you. Okay, 50 rupees profit for the company. But you are going to take a leave, assuming I am going to. It is a loss for 50 rupees. But it's a loss for company. If you see the loss for company, it's 100 rupees. They are lost. They are getting, as well as your cost, as well as their profit also, they are getting lost. Okay, it's better. That is the reason any productivity is very important for the employee. Just imagine, in one side, people are having a complete glazed building. Completely, it is a full glazed building. Why they are giving a glaze? Because you cannot work. Even in olden days, if you see net center, even 90s kid knows that very well. In net center, there it will be one smallest cabin. On left hand side, you will see one partition. Right hand side, one partition. Top one partition. Front one partition. You will be sitting in a small cabin. You have to browse it, or you have to gather the information. Okay, guys, please. It's a gathering information, nothing else. Okay, so there, if you see the psychologically, you will be very close, because you're sitting in a dungeon, or it's a ditch area. Moment if you are going to take the same laptop and sitting in an open space with in a terrace or something, there your productivity is going to be higher. That is the reason, though in foreign countries and other things, they are ready to invest on their infrastructure. They want to have a clear in view, so that people can have a complete view, and their productivity is going to be increased by adding a views in the sense of by connecting the people with the ambient. That is going to be a huge impact. Okay, so even nowadays, if you see, there is a lighting called human centric light. Human centric light is nothing but it is a light which is going to sense the atmosphere. Okay, just imagine during rainy season. Okay, during rainy season, around 3 o'clock, suddenly sun glows. covered by the cloud, you will feel one atmosphere. Yes, aha, nice climate, yeah, good climate. I love to work this kind of climate. Likewise, you'll feel right. That mood is going to be bring by the light fittings. Though its entire area is going to be closed, the light is going to decide whether what is the ambient condition. Based on the ambient condition, that is going to change it. Glow, that is brightness and dimness. I would say brightness of the, but general terminology called this lumen level or lux level, that is going to change it by the ambient condition. So that has been done by automatically. Now we have another dimmer control. They'll say dimmer control. You should aware of this technological terms. Okay, dimmer control is nothing but I can increase light by adjusting the remote control, or I can use iPad. I can increase or decrease dimming. Right, fan speed dimmer, fan speed regulator. Kind of same way we are lighting also. We can dim and we can reduce and we can increase it. But in a human-centric light, that is going to automatically, it is going to sense based on the ambient condition. These are all the lightings are very cost. Just imagine we are using a regular light of hardly. If we go to electrical shop, what will be the lighting cost? Can somebody say one LED tube lights or something? You should aware, because everything will be done by the father. We will have a nice food and we will just sit, but we don't know what is the expense. But we should know 40 rupees. Pana 40 rupees. They'll not give even box for you, lighting box. I'm talking about a regular LED linear fittings. Linear fittings means it's a regular light. 60 rupees. Ganesh, yes, it is 400 rupees. The cost comes around 350 to 400. Again, it's a brand, it's different. Okay, these costs you should be aware, guys. Come on. On those days, only the people used to go to, even Sir Anthony Sir also is there. So on olden days, he used to go and get this electrical part. The father will give an instruction, he'll go and get. Nowadays, everything has to be done by our parents. Okay, but you have to be aware of these costs. Maybe once the responsibility comes, then you will know exactly. Okay, so the cost of the lighting is 350, but the human-centric light costs around 4,000 rupees, 5,000 rupees. But still, people are investing on that, because with that advanced lighting technology, they are going to increase their productivity. Just please have a word. It is going to increase the productivity. Okay, so that's where they are investing huge amount on the lighting part. Okay, I have a lot of lighting technology, because why I'm covering this lighting part, again, that has been linked with the indoor environmental quality. In indoor environmental is nothing but indoor condition, entire thing. But in that indoor environmental quality, 80% has been handled by the air quality, fresh air quality. IAQ is different, IEQ is different. Please understand. IAQ is nothing but indoor air quality. IEQ is nothing but indoor environmental quality. Okay, but IAQ is one part of IEQ. Okay, got it right? So why I'm taking this information is, maybe you should aware of this information while doing your project. You have to highlight that I'm using a human-centric lighting. Why? If you are using these kind of different technological term, you should know, you should gather the information, then you have to propose. Then definitely the guy who's going to review, yes, he knows his stuff, he has gathered a lot of information. So you have to have a recent technologies for the lighting part. Okay, so lighting part also is going to be one of the factor in our heat load calculation. Anyway, so why I'm saying is, so we are investing very minimal cost on the infrastructure. I'm saying 4,000 rupees, 5,000 rupees lighting cost, but still adding those costs, I'm paying only 20% cost for infrastructure, 80% on the salary part. Okay, got it? Okay, fine. Okay, we will move to next slide. Okay, fine. These are all the standards. ASHRAE, selected pollution, OSHA. Well, like this, we have a different thing. Okay, so OSHA, it is nothing but don't take it in a different way. It is not something ISHA or something like that. It is a occupational some health association, something it is there. Okay, so these are the standard where they have already predefined the values. Okay, predefined in the sense, by doing some research, they have already loaded certain information in that part, and based on that, we are going to take it reference. Okay, so we know, right, anything, there will be a benchmark. I think I've already said there should be a benchmark for there should be a benchmark for anything. For example, air quantity, somebody has to say, right, somebody is keeping a benchmark for you, right? For you, what is the pass mark for your subject? Any percentage, in terms of percentage? Pass marks? Well, 50%. Oh my god, 40, 65%. Oh, everybody's having their own pass mark, right? There is no benchmark. Is it, sir? Is it, sir? You have a different marks for passing percentage, right, sir? Anyway, fine, no issue.
No. 50.
50 percentage. Okay, done. Okay, for Dinesh, I think 35 still is in 10th standard. I think Vignesh is having 65%. He is he's going to be a brilliant student, I think. So he is keeping his own benchmark. Anyway, 50% is a benchmark. So benchmark has been created by the college. So that is a standard. So Ishwari College is having a benchmark of 50% fresher or 50% pass mark for them. Same way, standard also is having certain fresher quantity. They are keeping some benchmark as a fresher quantity. This is a fresher has to be supplied for the space so that people can live in a comfort zone. Okay. So can you go to next slide? So in this ASHRAE 62.1, there is a different 2010, 2013, 2015, something like that. We have a huge thing, but it's your responsible. Just browse it, get the information of ASHRAE 62.1. That is going to be a standard referred for fresher quantity. Since our topic is relevant to IAQ, you should be aware of this ASHRAE. And again, also ASHRAE is having their own fresher calculation. You have to go through in detail. You have to come up with your response. Okay, so maybe during discussion after this thing, maybe you may have to know what is the exact fresher quantity that can be discussed in that discussion. So everybody download those for information, and we can let you know. Please let me know. Okay. And number two is this. You can see a pictorial representation of this complete part. How the HU and how the air is being supplied. What are the VOC content? What are the things that are available in the air? Okay. See, if you see, there are multiple particles placed in the air. Okay, so those particles has been directly filtered in the HU. If the moment the fume is, if the particle is getting clogged in the filter, by cleaning the filter, we can remove those dust so that it is going to be create a healthy environment. So we have a lot of things. If you see in a clean room, they'll say, have you ever heard clean room? Clean room. Any answers? Clean room. Yes, very good. So where it is relevant to? Where we are going to use this clean room? Which way it's going to be helpful? Come on, quick. Operation theater. Very good, Kana. Great, Kana. I think I have your. No, I have not taken your information. Hospitals. Kana, you have been very active, Kana. Okay, you just Shashwat Kana. I think you already given your contact number, right? Yes, I think you have a contact number. It's a good thing. And in stabilizing research, yes, we have a different thing. I'll tell you, this clean room is nothing but just imagine there is a medicines tablet manufacturing, right? You just imagine it's a very smallest tablet which is going to control the entire human body. If the particle is mixed with some dust or something, that is going to be a huge impact on your condition. If you take in a clean room, if you take a 1 volume of air, if you test the sample, that will have 1 lakh particles, ppm. They'll say 1 lakh particles. It will have a different chemical, water, dust, insect, a lot of things will be there. It is a 1 lakh class, but in a clean room, if you see, we have 1 lakh class, 1,000 class, 10,000 class, like this. We have a different classes. So 10,000 class will be chosen for the this tablet manufacturer or something like that. But there is a different specification given by the different manufacturer. But just imagine if you take 1 volume, it will be only 1,000 or 10,000 particle will be there, but still it will be there. You cannot remove 100%. But those kind of informations we have to give. We have to live with that condition. No other option. But any dust particles which is going to affect our process, that is going to be a very serious impact. And that's where even if I still remember in this trips, right? Glucose trips we used to take in the hospital, right? The trips also, they will directly pour into the bottle. Sorry, that plastic containers. They will not allow that trips to travel to the air. If you are taking a water bottle, just open the tap. You are placing the water bottle. The air is getting contact with the water, right? But if you see in this packing area, they will not allow that glucose or that will not allow that water to interact with the air. It will be directly poured into the container, so that airtight container, so there is no air has been interacting with the what is that trips. Okay, so that's where they are doing wonders. But we are living in a different condition, which is been very very worst condition. You can see lot of dust particles, virus. Now we have come across with the COVID, other things, and lot of people are saying that COVID is going to have a serious impact. That's a different strategy. Okay, that's a different subject that we will have separate session for that. Okay, so we have a lot of things. Even on left hand side, one bottom left hand side, you can see photocopier machine, right? Can you say what is that exactly on left hand side bottom? I'm expecting one answer. What is this? On bottom side, left hand side corner, one box, it is there, right? I've given the answer, but still I'm expecting answer from your side. Photocopier, very good. I am expecting. Ganesh, you got it, man. You are the great man. Okay, hold. I was expecting this answer. Xerox machine. Actually, Xerox is a brand. It's a company. Okay. Photocopier is a machine, or printer is a machine name. Okay. They have created a monopoly. Okay. So why I'm saying this point to you is, people used to create it in monopoly such a way that we are using the same terminology. Xerox is a company name who has manufactured that photocopier machine. Okay, so let us not use that word, because I know I was expecting this answer. That is the reason I questioned you. Anyway, it's not an embarrassing situation for you. Don't worry, everybody knows, but you have initiated with the answers. Okay, so it's a photocopier machine. Why there is in photocopier machine, will there be any fumes? Will there be any emissions? Yes, there will be emissions, because while taking the printer, if you take printout, there will be a small black thing it is getting, right? So that will emit with the ambient. That's where even in the office space, there will be a separate room called photocopy room or reprography room. In that room, we will have one supply air, and we will directly exhaust the air. We will not allow the fresh air, or will not allow that recycled air coming from the photocopier machine. They will directly take an exhaust, because while taking the photocopies, there will be multiple emissions will occur. So that should not impact with our fresh air quantity. Okay. Okay, get to next slide. Okay, so in that HUV, see, I'll tell you, I have very very simple. Another, I think Ramya. Sorry, I don't know why I'm saying Ramya continuously. Okay, Vishnu. 8 slides are there. Another 6 slides are there. I think almost on 14 slides. Am I right, Vishnu?
Yes, sir.
Okay, only 6 slides I'm going to take it. Okay, again, it's only I'm not going to bore you or something like that, because it's a very interactive topic. Maybe I can complete as early as, so that we can directly face to face or directly interacting after muting. Okay, so I'll just cover. See, this filter is a medium. You remember I was saying in AHU we have only 3 component. One is, can somebody text it? What are the different components of AHU? Come on. Somebody type. Come on. Or you just type one word. Okay, very good. Coil, filter. One more answer. Fan, filter. Very good. Okay, done. Okay, humidifier. Very good, yeah. You have a good thing. We'll discuss humidifier, dehumidifier. That's all very huge components. We will let you know that point, friend. But for this timingly, we can take it. Filter, coil, fans. These are all the 3 components, and the panels will be there in the HO. So in that filter is a main factor where we are going to filter the air. The complete part is going to be distributed. It has been filtered in this location. Can you come to next slide? So you can see different types of filters. MERV 6, 8, 11, 13. Can somebody quickly give an expansion for this MERV? That is an abbreviation. Meanwhile, we'll discuss. Okay. So MERV 6, it have a certain. I was saying that micron level, right? 20 micron, 10 micron. So MERV 13 is going to be efficient. Okay. Done. Ganesh, good. Yeah, you have made that compensation for that Xerox machine. Okay. Done. So MERV 8 is the medium rated filter. MERV 13 is high rated filter. That is, it's going to filter high, medium, and likewise we have another filter called HEPA filter, ULPA filter. Like those filters, that is going to be very, very high efficient, where it is not even going to allow certain dust, because these filters will be used in the operation theaters, okay, in the supplier side. So in operation theater, the whatever the air is going, that is going pure filtered air which is going to be supplied, because that is going to be a very huge impact. Okay, so the filters is having different filters. We have carbon filter, we have silicon filter. Likewise, we have huge varieties of filters are available with us. Okay, can you come to next slide? Okay, here we have done one exercise in our project where the AHUs are available. Okay, but unfortunately the VOC contents are very high. So what we have done is we have introduced one carbon filter in that location, because the carbon filter will carbon. Have you seen carbon, or sometimes you will see a kind of a silica gel, right? In any new packing, any newly purchased thing, you will have one small packet of some sand or something like that. See, that is for to absorb, that is going to absorb the humidity RH level, that is going to absorb, because the RH is, if the RH is very high, that is going to affect that thing. So by adding the silica gel, that is going to absorb the RH level, so that your it is not in a moisture condition, that is the life of that part is going to be a very good condition. Same way here also the RH, it's not about the RH, we have another chemical, other VOC content, PM levels are there. So to remove that, we have added carbon filter. You remember I was discussing that, right? The adding, sorry, MERV13 filter. You can see on right hand side fresh air unit. We have added one fresh air unit, okay, one new fresh air unit. Since in that project ambient condition, we have directly taken the fresh air and putting into the room. So for that we didn't do, because there is no filtration. If I add a filter in this AHU, I have to do a lot of modification in the filter. So that is the reason we have added a fresh air unit. There's a fresh air unit. You can see MERV8 filter, MERV13 filter, MERV16 filter. So I'm taking a fresh air, I'm doing a complete filtration in the fresh air unit and directly pumping into the AHU room. So the fresh air has been directly added, but the entire dust from the ambient condition has been filtered by the fresh air unit. But still I am having an indoor pollutant generation. So that pollutant has been removed by this carbon, activated carbon. You can see that, right? You can see that supply and return from it is going to cross in this activated carbon filter. This modification has been done in the existing AHU. Can you go to next slide? You can see on right hand side center picture, that is a fan assembly. You can see that in the existing AHU room, we have added one fan assembly in. On right hand side extreme picture, you can see in a existing AHU, we have added one plenum, kind of a small box extension. We have added in that carbon filter. So this modification has been done in the existing system, because now recently everybody is aware of this thing. So they are adding a lot of modification in the existing system. So that is the reason we have added in this location. Okay. So this is a project where we have done it, but unfortunately here the problem we have faced in this project is the ambient condition is not in a good position to handle the fresh air. So just imagine how the fresh air, oxygen is being generated within this space by taking the fresh air from the ambient, we are pumping it. If the ambient condition itself very worst condition, then what are the possibilities that can be done? It's very tough, right? So that is the reason we have added a different filtrate, so that we are removing the dust from the ambient condition and we are supplying it. Okay, these are all the things. And any other strategy, how can somebody say I'm expecting one answer? Can anybody say, is there any other point so that the fresh air can be generated within the room? I'm expecting one answer. I'm going to have a reward for this answer. A different, anything, can be anything. You just come up with the UV lamp. Okay, UV lamp is not going to generate oxygen here. Oxygen generator, yes, that is also good, but the cost of that oxygen is going to be huge. Yes, ozone generation is nothing but the oxygen. I think it is going to neutralize. It's going to react. Electrostatic filter, no, it is not an oxygen. Don't take it in the rocket science manner. It's a very simple answers. Mini plant, Dilly Babu. I was expecting the perfect answer. This is a.
Sir, this is Vishnu Priya, sir.
Oh, Dilly Babu, mini plants.
Yes, sir, I messaged it, sir.
Okay, fine. Vishnu. You just type your contact number and your mail ID or something. Okay. Sorry, done. I don't know something. Okay, fine. It's a good answer. This is the answer I was expecting. because see, if you see mini plants, there are money plants are there. There are a lot of land which is already done by our parents or grandparents. There will be a lot of plants within this space, right? But now they are selling the plants at huge cost because they are saying in a different terminology, this is going to generate a fresh air. Yes, the tree is going to our plant is going to generate some amount of it. Is not so far there is no proven technology. This plant is going to generate so much of air quality, so much of oxygen level. Yes, it has been proven that it's going to generate. It is going to handle some amount of uh, air. Okay, that is the reason for adding oxygen generator. Sorry, a money plant in the rooms. Okay, can you move to next slide? Okay, next one is this UV lamp. UV lamp, it's a trend. It has become a trend now. Everybody is talking about UV lamp. I don't know what everybody is talking about UV. UV lamp was a very long, very old thing which is available in the market in long ago. But even if you see in our specifications also, we will in whatever the age that we have provided, we will ask the client to have a spacing for the UV lamp. Okay, though the costing of UV lamp is bit higher, but we will provide a spacing in that UV in the age choose, because in future anybody want to answer, if you want to add that UV lamp, we can add in the H2 component. You can see a gap, right? On left hand side you will see a filter, on the right hand side you will see a coil, right? So there should be some minimum gap. If I'm going to reduce the gap, then the reaction time or the interaction with the lamp is going to be very lesser. So that is the reason we should have a decent thing. And moreover, the selection of UV lamp is very critical. If you are selecting some, the vendor is supplying, the vendor is going to supply is having a different lamp of different wavelength, means that is going to be a huge impact for you. It's not going to impact. It's not going to save you. It is going to destroy you. So that's where we have a very critical UV lamps are available. But there will be, along with UV lamp, there is a called photocatalytic thing that is going to quicker the reaction. In chemistry, we would have run it, right? Catalyst is nothing but it is to speed up the process. The same way here also, it is going to speed up the thing. Yes, you have raised a question. Yes, UV lamp is dangerous for skin. Yes, it is. The wavelength again depends on the wavelength. Okay, so UV lamp is being used for skin cancers, or it is being used to destroy the lot of skin treatment. But the same UV lamp is being used for in a good manner. Yes, selecting a appropriate UV lamp with the required wavelength. The standard has given so and so wavelength. So what are the particles going to be destroyed? So based on that thing, we can select the UV lamp. But still, it is dangerous. Not up to certain wavelength, it's going to be dangerous. Okay, fine. So the UV lamp is very critical here. Nowadays, everybody is come up with UV lamp. You have to place it. Maybe in our project also, we will have a UV lamp provision that is going to be remove some amount of virus or something like that, which is being interacted with the airborne diseases. Okay. Next slide, please. So this is another technology called air purifier. Air purifier is nothing but they are, right? Any bigger technology, there will be some competition for that. They will have very compact things, right? Hey, the same thing here also it has happened. It is going to be an air purifier is nothing. It is a small box where you can see the different filters, right? So it is going to be placed in the AHU only. Sorry, not in AHU. Still the AHU will be there in this space, but still we are going to place one small box so that is going to cover certain area. Okay, that is going to cover certain area. Based on the area, this box can be selected. You will have a lot of. It will have a fan that is going to take from the top and it's going to discharge from the bottom, and whatever the air in that area, it is going to take and it's going to have a filter that is going to filter it. And they have a lot of another it's a bigger version. This is going to be a very smaller version which is available in the market. Again, if you see, this purifier is being used for gym. Any reason why we are using this air purifier in the gyms? we respirate a lot. Very good. So we respirate a lot. Yes. Not only that, sweat generation. Yes, exactly, sir. I was expecting the same answer. Sweat generation. See, just if you keep on doing exercise, there will be a lot of sweat. Unfortunately, if you are giving with a separate unit for the gym, yes, that is going to be a closed circuit. So within that room, that is going to be work. But if you are connecting with the office space with the gym, you know, right? Gym office are coming up with the gym. Please, guys, you should be very aware. In an office space, you will have mother's room. You will not come across those points. You will have a mother's room. You will have a phone booth. You will have a play area. You will have a creech area. You will have a children's taking room. So likewise, we have lot of facilities available in the office. Just imagine mother's room, there will be separate room for that. Okay, you will have a separate design for mother's room, and it has to place in such a way there should be a water point. Likewise, we have different rooms are available. If you come across the office space, there are almost some hundreds and thousands of varieties of rooms are available. Okay, just imagine for small cafeteria, bigger cafeteria, breakout area. Other than office space, you will have entire thing. Because I was saying, right, the productivity is very important. There are productivity is very important. Productivity is going to take the company to a next level. So the people are giving a relax. Just imagine in a college, if you are roaming here and there, they'll teachers will call, hey, why you are roaming here, which department, like that, they'll question, right? In office, they'll not question. Don't worry, why you are roaming here and there. You will be given certain time. Within time, you are completing your work. Nobody is going to question you. Okay, so there will be play area. There will be snookers. I still remember. I was going for an architect meeting. So I was waiting for architects before entering into the office. So nobody is respond. I asked security and just I entered. Everybody was playing snookers. Okay, just workstation has been designed. It has been placed in some corners, and in a center of office, they are placing a snooker. That to Monday morning 10 o'clock, everybody is playing snookers. Okay, just imagine that's a way you have to be work, because our mind should have very relaxed thing. Then only we can focus on the job. Okay, even I say, sir, I'm waiting here. Yes, you'll be there, man. I'll come. Like that, he said, and he started working. It doesn't mean that he's not working or he is not interested in the project. But everybody wants some relaxation, right? So that is the reason you were playing. Everybody was having their own different working strategy. Okay, say the IT companies has created such an atmosphere. So we have any productivity depends on this kind of atmosphere. Why I'm saying this thing is, when the student comes from the college, they will have a lot of burdens. But in the sense, book knowledge, book things, so they have to have an exam, classroom, test, a lot of things you will have. Once you come into the industry, you will not have those kind of things. If you want any answer, you can browse it, you can take a book, or you can get the information, you can gather and you can say. But in a college, if sir is asking some question, if you're taking, sir, I'll refer this book. If I'm going to take that information from him or something like that, they'll screw you. Okay. But if you see in a work culture, I just wanted to highlight why, because I've seen a lot of students. They'll come, sir, good morning, sir. I want to take this information, sir. I want to do this information, sir. Can I go to bathroom, sir? Likewise, a lot of things I've seen it, but you should not do in that way. Okay, once you come into the professional industry, that's a different strategy. So it is not only I'm not going to cover only the IAQ. I'm going to cover the industrial ones, because you are going to start your career. Okay, the career has to be in such a way, you have to be very smart. Okay, fine. So this in a gym, if you are putting a air purifier, that is going to absorb the sweat. That sweat is going to react with it. Just imagine, your friends or somebody is coming in from the gym, you will see how sweat it is. Okay, that is going to be in bad order, right? That's not a good for health. Same, that is not going to be affect the health very serious, but they'll not feel that, they'll not like it. So that has to be removed, right? For that only they are putting in a small air purifier. This is a recent trend and technology. Everybody is come up with this small air. They'll say air purifier. By adding this, your life is going to increase for another 10 years. Like that, they'll do a lot of marketing, but the concept remains same. You can see the filter, right? Regular air conditioning part. These are the things. So I've just elaborated the presentation. So air quality, from where we are generating the IAQs, that is IAQ in the sense pollutants from the paint, from the carpet, from the human, from the ambient, from the pet. Like this, we are generating those things, and how we are removing it. We are removing through AHU filter, we are removing through UV lamp, we are removing through air purifier. These are the strategy to remove this thing. But unfortunately, the fresh air calculation, you would have heard, right? Fresh air calculation. The amount of fresh air is being supplied from this area to space. That selection of fresh air quantity is very, very critical. But unfortunately, nowadays, nobody is giving any fresh air for this space. Okay, because the more the fresh air, it's going to have a load, maintenance work, a lot of things are there. So I have just briefed it. So with this, I'm going to close this IAQ. So any clarification I want to spend a good time with you, so that is the reason I've kept half an hour time, so that we can interact. Anytime you can unmute and you can raise your question, we can interact. Maybe if you want, I can extend from 4:30 to 5:30. 1 hour is also fine for me. And I would like to add fresh air quantity. So with this fresh air strategy, how to handle it, we are closing, but small system selection. On what basis system selection? I just have another small 3-minute session. I'll just share the pictorial representation. So we have been seeing some layout, right? So in that layout, again, I'm having a system how there is a individual ductable unit can be placed in an individual role, so that this is going to be in a good system. But unfortunately, the noise level is going to be in the cabin, is going to increase. Water maintenance, anybody, if any unit fails, then suddenly the maintenance guys will come, they enter into the office, they will remove it. So likewise, we have different things. Okay, so this is going to be a separate unit for the cabins. Can I go to next slide? This is going to be an underflow distribution. Underflow distribution is nothing but, can you come to next slide? Okay. Oh, previous slide. I didn't pick that pictures. Okay. So previous slide, please. Okay. Here, so if you see here, underflow distribution is nothing but adding air from the bottom, and we are taking the return in the false ring. Okay. See here, the concept is very simple. There is no cross contamination. Okay, because all air is being supplied from the bottom, and the particle dust is getting taken from the top. Okay, but if I am going to supply the duct from the top, okay, from the top again, I'm going to have a return from the top. Just imagine there will be a turbulence that it's going to circle in this state, and it is going to hit again on the top. Again, that the return dust is going to come down. So there will be a turbulent effect which is going to mix that contamination within this space. But if you see underflow distribution, the return path always it's going to be on the human above the human breathing level. So entire dust has been taken above, and the people in the breathing level it's going to be in comfort, because the entire air has been taken. It is in from downward to upward, the air has been directly taken. Okay, but in the previous, on the right hand side, you can see the image. A guy who's water is pouring, pure water has been poured on the top. Again, it's getting mixed, and again it's getting overflow. But on the right hand side, if you see the air, pure water has been poured from the bottom. Automatically, the top air is getting returned. So this is a good pictorial representation. I feel that is the reason I've just shown it. So this is going to be an underflow distribution system. Yes, we can do even in our project also. We can say, sir, I'm not going to design any duct. I'm going to have a fully underflow distribution cooling. Okay, this has been done. We have done this project. Maybe after this call, maybe I can show some images. Okay, next slide, please. This is another technology called radiant cooling. Radiant cooling is nothing but, so once we calculated that load, right? So we will give a AHU capacity. For example, heat load comes around 50 tons. So we are going to give 50 tons of AHUs. Okay. But here in the radiant cooling, we know what is the envelope load. Okay. So we will lay the pipe, chilled water pipe, along with the civil construction. During civil construction, I'll lay the pipes, multiple pipes in the space. Okay. In that space, so that I'm covering the concrete. The moment I'm going to run the chiller or something, the chillness will be emitted from the wall. Okay. So directly it is stopping the heat in the peripheral area. Okay. The heat has been directly stopping, so that I'm not giving any fans. Just imagine the capacity remains same, but earlier I'm giving 50 TR with 8,000 or 10,000 CFM, but the same capacity I'm giving 20 TR in the peripheral, but I'm not adding any fan, and 30 TR of H I'm supplying it. I'm adding only 7,000 CFM. Earlier it was 10,000. Now I'm giving 7,000. By reducing the air quantity, the lesser air quantity, I'm going to have an efficient IAQs, right? Okay, if I have very lesser air quantity, the contamination, the crisscross area, the turbulence is, I'm just avoiding it. So this is also one of the good selection. Radiant cooling also is a good selection. Even we can try for this. Maybe I can loop you to our radiant cooling vendors, so that you can get the technical support from them, so that you can propose radiant cooling for this IT office. Okay, so it's all imagination. We can have a better system. So we will discuss, maybe upcoming days we can have a discussion on this part. Okay, next. But the intention why I am saying this point is, earlier the capacity, I'm saying the capacity remains same. The fan delivering air quantity, the air quantity plays a major role, right? Taking the pollutant to a different area, but I'm avoiding 50% of air quality. So I'm avoiding the air taken by the pollutant in a different space. I'm avoiding it. Okay, this is one of the good system for maintaining better IAQ. Can you go to next slide? So I was saying, right, cross contamination, conventional central AC, yes, high, but effective air mixing, poor. But dedicated cross contamination, medium, but fresh air mixing, best. Underflow cross contamination is low, fresh air is good. Radiant cooling, there is no cross contamination, but it's the best way. So radiant cooling is one of the best system where we can use this part. Okay, so move next. So I think I've almost have completed this part. So I have had this system selection because it is how the IAQ is relevant to this building design and system selection. Okay, so that is the reason I wanted to add. So let us have question and answer sessions, so that we can have a good interactions. Okay, so Anthony sir, I'm closing with this presentation. So let us have a question and answer session, so that we can discuss.
Yes, sir. Thank you, sir. Thank you for your very good presentation. Sir, okay, so we have few questions here. All the inventions are mostly for indoor. Air purifier is in public places at a mass quantity. For example, air purifier at a bus stand. A lot of people inhale toxic substances, smoke from the vehicles. Would it be efficient? Arun Venkatesh.
Understood. Venkatesh, to answer your thing, see, we are discussing on the indoor connections. Okay, we are discussing on the space within this. So it's a closed room. So the water in a closed room, whatever the dust is being generation, that has to be removed. But unfortunately, if you see in a public mass area, since it's going to be an open conditioned area, yes, we don't need to consider these kind of thing, because since it's going to be an open area. But if you have a huge bus stand with a conditioned area, yes, we have a different strategy to remove this thing. We can have a pre-filter, we can have a carbon filter in the HRW, so that it is going to be. What I'm trying to say is, it has to be closed condition space. That's my concern. But unfortunately, if you are asking in a bus stand, yes, obviously bus stand will be there. It's going to be exposed to the atmosphere, so that cannot be avoided unless until we have to come up with the green transport, like battery operated bus and atmospheric pollution. So that's a different subject, Tarun. Hope I would have answered your thing.
Also, I think it is beyond the scope of today's discussion. We are discussing for a IT park. Okay, so I think it is beyond the scope of today's discussion. Okay.
Okay,
Fine.
thank you, Tarun.
Yeah, so I have one question. Okay, so there is one more. We will complete that, and then I have a doubt about on underflow circulation. Won't it be disturbing while walking, or won't dust be from the shoe block the airflow in a underflow circulation system?
Okay, understood, sir. See, yes, you're rightly said. There will be multiple air terminals, sir. The air terminals also, if you see, we will not give the air terminal in the corridor, because people used to continuously walk. Okay, so the air tile will be placed in such a manner, and moreover, if I'm taking that what is that air at 12 degrees Celsius and placing in a 12-degree air from the floor, yes, that is going to create a worst situation for the employee, because the chillness, they cannot sit at 12-degree air supply. Okay, so there we will design a elevated temperature where the outlet will be around 20-degree or 18-degree. When compared to 12 degree, this is going to be an efficient system. And moreover, yes, in a project, we have placed the thing in the corridor or sorry, in a workstation, people used to travel. No other option. They have to live with that because that is not going to be an effect and it's not going to break because all air terminals has been designed to handle up to 500 kg per thing. So that is the best. Where we can withstand it. Yes, people can cross. They can have. There are air terminals where some people will come with a lot of dust, right? So they'll have something. They will stand. Then the dust is going to gather within the air terminal. By removing the air terminal, we can remove that dust. It is having some cup provision. Yes, it has been designed for that, sir.
Okay, sir. So next question we have: will maintenance be easy in underflow system?
Maintenance, you see, just imagine maintenance free, I would say, because in a ducting system, the moment it is getting dust, we have to clean the duct within the space. But here there won't be any maintenance because I'm going to create a false flooring. Just imagine, guys, I'm going to raise the floor, I'm going to put a false flooring. Okay, false flooring is nothing but uh, uh, there will be a physical tiles which will be projected up to 800 or 400 something like that. Maybe I can share some image. I'll take it right away. CB. Sorry for showing my thing, but I'll just get that information. We have done a project in Coimbatore. Okay. I don't know, something happens. Couldn't get that information. Okay. Anyway, I'll share that image maybe once that group is there.
Share it in the group, sir.
Okay, done. Maybe I can share from the internet, right? That's also possible.
Okay. Sir, I have a question.
Yes, sir.
This radiant cooling system, will it be, won't it produce condensation in the high humid places?
Exactly, sir. So this is going to be a very good question, sir, because we in a radiant cooling system, we will not operate a chiller at 712. We are going to operate at 15 degree or 20 degree chiller. That is one thing, and we will have very limited fresh air quantity. But still, not limited. We will have an excess fresh air quantity, but that fresh air will be treated so that is going to remove the moisture. That is not going to add a moisture. So there won't be a directly fresh air pumped into the room. That will be treated and it will be pumped in the room. Okay, and that is one thing. And we will have one ant space. They'll say ant space, right?
Sir, again, what is the temperature of the coil in the treated fresh air unit?
If you see, that set point will be 22 degrees, sir. 22 degrees.
No, in a treated fresh air, what will be the coil temperature?
Coil temperature will be around 18 degrees, sir. 18 degree.
And I have one more question to ask.
Yes, sir.
If you are maintaining a very high ADP in the cooling coil, condensation, humidity will not be removed. In the room, we will be having a higher humidity. Okay. So that means on the bacteria and the mold side, we will be having problem. Am I correct or not?
Yes, sir. See, that's how we will do it actually, sir. See, we to remove if in a room we have to have some we have to remove that humidity and should have a decent thing. So we will have a fresh air unit which will be treated, and that outlet it's going to be in 18 degrees, so that with that fresh air the moisture is not going to be added in that area. But I'm going to have a radiant cooling, but still that coil will be there, but the whatever the supply degree whatever the refrigerant
I know that when we are going for a radiant system, we have a dilemma. We cannot go for a very high very high temperature because it is not going to remove the moisture. And if you go on the lower side, near humid place, it is going to cause condensation. So,
Yes, sir. That's what. See, the moment the fresh air is being added externally, then there will be a condensation, sir. Because I am sizing the coil based on the indoor condition.
that is why I'm asking what will be the temperature in the treated fresh air unit. If
It
the
will be around.
temperature,
It will be
if you
around
are
18
maintaining
degrees,
at
sir.
18 degrees, again the water, I mean humidity will not be removed. At least you should maintain it at below 10 degrees so that the thing moisture will be removed from the fresh air and you can pump it inside the room. Okay, I think
Sir,
it is a
sir,
bigger. Yeah,
I'll share that. We will discuss separately, sir. I'll just share that that
Okay.
psychrometric, sir.
Yes, yes.
Okay.
Okay, fine.
Okay.
Any other question from the participants? You can unmute yourself and you can talk.
Okay, there is a question on the BRF system. If a company needs approximately 300 ton, then in that case, BRF system, single odor is advisable or multiple odors? Okay, I'll tell you. In a market, if you see, they'll say HP instead of TR, it will say HP. Okay, so assume 1 TR equal to 1 HP. It's not an assumption. It will be 1 TR equal to 12 HP approximately. Sorry, 1.2 HP. But I'm saying up to 100 HP or up to 60 HP, you can have a combination. Again, it depends on the different vendors. I can say 60 TR. So 3 modules can be connected commonly as a single output. Okay. Box 1 is 20 TR, box 2 is 20 TR, and 3 is 20 TR. So 60 TR can be combined and I can put as a one circuit. That is the recommended size. Above 60 TR, it is not going to be a thing, because just imagine if the refrigerant pipe is getting punctured inside the building, the amount of refrigerant which is going to be pumped into the room, that is going to be very serious impact for that. Even in foreign countries, they will not allow more than 30 TR or 30 HP within the space, because they should have some decent, their safety factor is very important. But in India, we are using up to 60, up to 60 HP. Some vendors giving 80 HP, some vendors giving 100 HP. But it is recommended to have a multiple ODUs for not for 300 tons. We can have 60 TR one set, another 60 TR another set. Likewise, we can go with the up to 60 TR.
Yeah, I think it will help in efficiency also, avoiding part load efficiency also.
Exactly, sir. Exactly, sir.
Okay, so any other question is there? The participant can post your questions. Sir, any way to recycle the dust from the air filters? Anyway, Mr. Tarun is asking, is there any way to recycle the dust from the air filters?
Sir, dust, again, see, dust is nothing. It's a useless part. Okay, so if see, for example, there are in an industry, if you see, they will clean certain particles. And there will be H which is going to filter that dust. So not dust, it is a particle. That particle will be reused for other thing. But for office space, dust, it's a useless for us. So it is not required to recycle it. We can directly remove. We can water wash it. We can put it. So that dust cannot be recycled, but something process related things can be done in an industrial thing. If you are using some chemical or some dust for some cleaning purpose, the same dust will be gathered in the filter, so that can be recycled to for reusing purpose. But office space, it is not recommended. We cannot use it.
Okay, sir. I think we have had a full session. So I think from the as a whole, this is I think most of the questions are coming from the current session. So
Okay.
as a whole, from the program point of view, if you have any query regarding the NSDC or any other point which we have left out, okay, so maybe energy modeling or anything like that, okay, so you can ask questions. Okay, so we have another 15 minutes we can utilize for that purpose. So you can unmute yourself. A few participants are very active, so you can unmute yourself and then you can ask the questions. This is the time you should ask questions. After this, you are going to work by yourself. Okay. Of course, we will be supporting you technically. So if I think there is no other question. Okay. No question is coming from the participants. So that means I think we have done a good job. Okay. Next is we will go for the valedictory, okay, or the finishing function. So in that, okay, so we will have feedback from two of our participants, and I have not answered one of the question. Okay, so from the morning, the participants, they have been asking whether the videos will be given. Okay, so definitely we are going to give the video, but I didn't tell because if I say if I am giving the video, so you will not attend the class. Okay, so for that purpose, I didn't answer your purposely. I didn't answer your question. Okay, so definitely we will send the video of the today's discussion. I think it will be useful for your for your preparation for NSTC. Fine. So the next is I want two of the participants. You can unmute yourself and you can give feedback about the program. Okay, so how the program has been organized and any improvement you want. Okay, so that you can open it and there is nothing to hide. You can openly tell what are all the feedback you have in your mind. Okay, so anyone volunteering?
Sir, it's better people please be open. So even if you don't want to say name or not a problem, but we need your real feedback because that is going to help for
we are
maybe
collecting. We are collecting that we are collecting separately. It is going on. That
okay,
work is going on. Yeah. That separate in a Google file they are collecting the feedback. But I want some two of them they can present themselves and they can give their feedback about the program. Okay. So
okay.
since they are not coming forward, I will call few people because some of them were very active. First, I would call Sharath Prasanna. Sharath Prasanna, you can unmute yourself and give the feedback for the program.
Good evening, sir.
Hello. Yeah. Good evening.
Yes, sir. Actually, the session was useful, sir. I just got many informations and many of my doubts were clarified.
Okay.
Thank you so much, sir. It was really informative and useful.
No, I want you to give some area of improvement. So please adjust as some area of improvement. Okay.
Sir, might be the break in between the earlier session and the current session might be quite. You might have increased it, sir.
So we have to improve break time.
Attending the classes is actually quite like was like not okay, sir. Only that one. That's
Okay. Yeah. Okay. Fine. We have taken your point. Okay. So we have taken your point. Very good. Okay. So we can have. So anyone else who is volunteering to give feedback? Yes. Mr. Anurag from Pondicherry.
Sir.
Yeah, you can unmute yourself and you can give your feedback.
Sir, actually this session was very useful. Why means when I received that flyer, that competition flyer, no, I'm just blank. I was trying to get information to many people, industrial people, but they are not. They didn't help me because they are fully their work. But this session, no, exactly. I was searching for some points and I got that here.
Okay.
And before that, sir, I have one doubt.
Yeah, please.
Sir, can you explain what is V-duct?
What is?
V-duct.
I don't get you.
V-duct, sir. V-duct.
V-duct. V-duct. I think they can explain. Okay, so Regobert sir will be explaining.
No, sir. V-duct means what exactly I couldn't get you. V means what text V means because there is no. Can you spell it?
Alphabet V hyphen duct DUCT.
See, there is no terminology, Anurag, because see, duct it's a rectangular duct. There is no specific terminology for that. Maybe from so far we have into the industry, we have not come across the terminology. Maybe if you can have some image or so this is going to be considered V-duct or something, you can just share it. But there is no terminology V-duct. Okay. Okay, sir.
So I think there is one more person, Mr. Ganesh Kotapalli. You can unmute yourself and you can give your feedback, Mr. Ganesh Kotapalli. So we are getting from different states. See there. Okay. Mr. Sai Aswin. Mr. Sai Aswin. AJ.
Yes, sir. I'm audible.
Yeah, you can unmute yourself.
Actually, in today's session, I learned about the heat load calculation more briefly, sir. And I came to know about the indoor air quality unit and what are its effects and a type of air conditioning systems for various heat load capacities for which we can use it, sir. And this session was very much informative, and I'm very much thankful to the staffs and the faculty members, sir.
Okay, thank you, Sai Aswin.
Thank you.
Yeah, so I think we had some sample feedback. Okay, so I think there is no other except that we have taken more time and we are not given break. So other than that, I don't think. Yeah, there is. Okay, Mr. Dhanush, you can.
Sir, good evening, sir. Sir,
Good evening.
It's a very good session today. I have one feedback to tell. It is very easy to have a 2-day session. We can split this session, this 1-day session into a 2-day session.
Everything you have given in 1 day. Yeah, okay.
Because we have some semester classes, online classes also. Today we have some 10 to 11. We have college classes, so we can't.
So we will. Yeah, I think we are going to form a WhatsApp group for the NSDC. For NSDC, we are going to have a WhatsApp group. In that we will. Okay. So based on requirement, also we can have sessions. There is absolutely no problem. Already I have got instructions. Saswat. Okay. Saswat will take all your numbers and he will form a group named NSDC. Okay. So you can post all your queries. If at all, if you are having any queries regarding designing or regarding load calculation or any designing aspect, you can post your queries. So in that group, Mr. Rego and Mr. Raj and Swaishali, that group. Okay, and we have one more, Mr. Ganesh also, it is there. So they will be helping you. Okay.
Okay, sir. Okay.
So they will be. What I am saying is that there are help from the industrial experts. It is for you to take the help. Okay.
Okay, definitely, sir. Definitely. Thank you.
Yeah, and we are going to send this video also to you. So that should. So you can any prerequisite is required. You can study yourself, and after that you can read video and you will understand. Okay.
Okay. Okay, sir. Thank you, sir.
Okay. Thank you. Thank you. Sir, HOD sir. HOD sir.
Sir, வணக்கம் சார்.
சார் நீங்க சொல்லிடுங்க சார். We can conclude sir.
சார் வணக்கம் சார்.
Yes sir.
சரி சார்.
So hello.
சார் சொல்லுங்க சார். சொல்லுங்க சார்.
Sir, you can give your.
சார் கேக்குதா சார்?
கேக்குது சார். நீங்க you can give your speech sir.
Okay sir.
Yeah, we are concluding the session. So you can thank everyone and we can close the session.
Okay sir. Okay.
Yeah.
Yes sir. So I thank History Chennai chapter for giving us this opportunity to host such a wonderful program. So I thank the chief guest in the morning who has joined us and all the resource persons who have joined us. So they have given a wonderful session. All the participants would have benefited by and large by this program. I request Dr. Anthony to have many more programs like this, and Dilli Babu sir also to have many more programs like this for the benefit of the student community as well as the faculty for their own development and benefit. Also, at this juncture, I would like to congratulate Ishwari Students Chapter for getting the Model Chapter Award for the national level. And I thank ISRO Chennai chapter for mentoring us and together guiding us through all these last 3 years to get this. I would like to congratulate Dr. Prasanna Raj Yadav and Dr. Dilli Babu, who are the coordinators along with the, and also our Andy sir, who has been elevated as the South Zonal Chair also. So that is also an achievement. And all these things are giving a very good image about the history student chapter of Ishwari Engineering College. So I'm happy for the, and all so many participants have taken part in this program. I think you would have got a first-hand information about the design and other and concepts as Andy sir was briefing in the morning. So this has been a wonderful day of learning, and I thank all the office bearers of both the Ishwari Chennai chapter as well as Ishwari student chapter of Ishwari Engineering College, the office bearers, the student coordinators, and all the organizers for the wonderful program. Thank you, Anthony sir, Dilli Babu sir, and all the office bearers of History Chennai chapter and Ishwari. Thank you. I have, and then one more information I'd like to add. Thanks to Dr. Anthony, who has inspired me over the last 2 years. I have myself become a member of History thanks to Dr. Anthony's friendship and association. I hope to be a member who is learning more about these areas of heating and the R&AC also. Thank you for having me as a part of this event, and thank you for the wonderful program, sir.
Thank you, sir. Thank you very much. As a convener for this program, I will also like to extend my sincere thanks to my management, History Chennai chapter colleagues who have given their support for conducting this program. And first and foremost, most important, my gratitude should go to Innoval International Solutions Private Limited, because the experts from Innoval Solutions, okay, so they are all extending their support. If you want to know, yesterday we had a session at History. Okay, so Mr. Sangadir Selvan, he was handling a 3-hour session yesterday, and we may be all knowing we had a 1-week session, Tech Talk. In that, almost 3 or 4 sessions was handled by Innoval Solutions, and today full session it is handled by Innoval Solutions. So this company Innoval Solutions, they are always ready to serve the students as well as the history members. Okay, so I think I have a lot of word of praise for this company. Okay, so sir, please convey my regards to your Mr. Kunasegaran, sir.
Sure, sir. Sure, sir.
Yes, sir. So it was indeed a pleasure to interact with you people, and you are very interactive, and we are ready to support also. So you are ready to support even after the program also. So we are very happy. So that sort of thing is very good, sir. Mindset to help the students. Okay, even after the program. Okay, so it's I think it's something big. Really, we will, as per your idea, we will form a group, sir, and we will include you, Mr. Sirajuddin, and as well as Mr. Aishali also in that group. And I would extend my sincere thanks to Mr. Siraj, because in spite of the today's festival, so he joined and he made a presentation. So please convey my regards to Mr. Sirajuddin, sir.
Sure, sir.
Yeah, and then for the participants, so though we have a few participants, all are very attentive and they listen to the programs. I think this time we are going to that is from the south, we are going to win this NSDC, because we are doing a lot of homework. Okay, so I'll be very happy, either the students from Ishwari or from other colleges. If anyone from south, if they are winning, we'll be very happy. So because that will be the outcome of this program. Okay, so I want all the students not to lose your interest. So but you have to kindle your interest, and you have to register yourself for this program, and you have to participate in the program. Okay, so you have to make the design, and you have to make the presentation. So you have to learn a lot of subject, and you have to do you have to apply your knowledge, and you have to ultimately you have to win the competition. Okay, so that is my wish. So I thank you all the participants for joining with me. Also, I wish to extend my sincere thanks to History Student Chapter of Eastern Engineering College. So all these guys are very dynamic. So they are. So you would have seen all the participants. You would have seen. So all of them are here. So they are extending their support for the conduct of the program. And also, I would like to extend my sincere thanks to the staff members. Okay, staff members of Eastern Engineering College. Uh, uh, Thank you, everyone. And with this, we are concluding the program, and we are not concluding our help to you. So we are there to help you. So we will form the groups. Please be part of the group. Okay. So any help is required, you can post it in the group, and our innoval experts, they will be helping you. Okay. Thank you very much. So it was a brilliant association. Okay, so it was there was a lot of knowledge dissemination. So I am very happy. Thank you, everyone.
So thank you, sir. Thank you, students. Thanks a lot. All the best. Keep going.
Thank
Thank you.
you. Thank you, participants. Dilip Babu sir, you want to talk? You can talk.
No, sir, we can wind up the session, sir.
Okay, thank you, everyone. Because we had a very exhaustive session, so please relax yourself. Okay, at least 1 or 2 hours, relax yourself. Then you can go for the next program. Okay, thank you.
Thank you, sir. Thank you, students.